Hello everybody and welcome back to another video. Today we are looking at a past event. This was a year ago, the little tornado outbreak that occurred in Chicago area. So lots of population in northern Illinois, and there were 13 tornadoes that occurred, 3 EF1s and 10 EF0s. This was a day that kind of came out of nowhere. The outlooks show this as well. You can see right here, here's our 12Z outlook and our risk area, which there are reports as well. That tornado area wasn't even in the 2% for most of these reports weren't even in that 2% risk. This is kind of a sudden change that occurred very quickly. Here's our 13Z outlook, 1630, and then 1630 they added a little 5% tornado region. At 20Z, which is 3 o'clock, they added this enhanced region, a 10% hatch risk for tornadoes. So they were seeing possible significant tornadoes occurring. We're going to be looking at it just the event because as the other events on this channel, this one does hold a special place in my heart, as this is actually my first storm chase. I got pretty bad footage of it in all seriousness, and this was also a whole year ago. I was very amateur at it, but this is the extent of what I got. This was a little bit of like what looks like rotation ahead of a storm. This is a storm that produced 15 minutes later, so that's why this event holds a special place in my heart. We're going to be looking at our archived data here. So this is the meta-analysis page. If you're not familiar with it, you just choose a day. I'll be going to 2023, and actually, because today is the year anniversary of it, going back in time just 1 year. I'm going to go to forward 24 hours as well, just so you can see ahead. We'll do it 12Z. Now we'll start at 16Z for some. No, we'll do 12Z, 12Z. We'll go to this. We'll start at the upper air data, 500 millibars. So here's our upper air data. You can see that trough that moves its way through. Here's 19Z. You can see a pretty well-defined trough up here. And not, is it super, it's like those really high amplitude ones you see over the Rockies all the time? No. You can see for the most part, there is this flow right here, and that is curved. That's your trough right there, and this slowly moves its way through our northern Illinois regime. For the most part, this wasn't the main forcing. It was actually a 700 millibar trough, which we'll get into in a second. And for the 500 millibar flow, it's pretty widespread 40s, some 50s, and even some 60s knots at this point. Going to the 700 millibar level, that's where we see short waves. Here you can see a very, very well-defined short wave that moves its way through. The issue was this was not very well shown in the models till basically right before this event, and that's why they had a very quick uptick in severe potential. So again, as we saw in the outlooks, at 12Z, this risk area was barely even included, including 13Z. Both of these barely had our risk area in it. And then at 1630, suddenly 5%, and then 20Z at 10% as well. 700 millibar trough right here, though, that would be our main forcing of the day. You can see as that moves through, extremely quickly after, that's when storms would form. Storms started somewhere around late 4 o'clock into 5 o'clock, and then very quickly ramped up. Finally, look at 850 millibars. That would be our low-level jet, and that should help as well. Checking strength is a little bit difficult with this map. I believe wind is in knots, so we're kind of looking at the barbs, but at least 30 knots of flow going into this, so pretty strong low-level shear. Also looking at temperature and dew points, the dew points were already in the 60s, high 60s, sometimes even hitting the 70s at this point. You can see one bit right here at the 70s, so pretty good for that. And I believe temperature wasn't super high, so it led to a pretty good temperature dew point spread for severe weather. Lastly, I'm looking at a few of the other multi-parameters here. Here's MU Cape, our instability, record instability for the region. For the most part, it would hit 2,000 for most of the day. See that 2,000 a little bit right here. I'll circle it right in here. See that 2,000 it says right there. That's 200 joules per kilogram. Is it exceptionally high? No, but if it's enough to get the job done, it's enough instability, and there's plenty of shear with this system as well. And finally, of course, 3 Cape and surface vorticity, something we've seen a lot, and this when these kind of bullseye together, that's often when we look at tornadoes. You can see our 18Z, we don't have any bullseyes yet, but just a little bit forward, all of a sudden 75 joules per kilogram of 3 Cape and plenty of surface vorticity in that area. 21Z, storms are firing right here, plenty of 3 Cape again, and a lot of surface vorticity. Into the overnight, that bullseye continues. Then as you start getting to the late evening and the sun goes down, you lose that Cape. And then after that we would end up with that system that happened in Michigan. So if we look at our tornado tracks, you have one tornado there in Michigan. See that through Cape and surface vorticity. That. Looking at other stuff on the Chicago website as well, we have the maps we looked at. This is 300 millibars, so that's even higher up in the atmosphere. You can kind of see this jet streak because of the stronger winds moving its way in. All of these are taken at 23Z, so this is right as a lot of the storms were ongoing as well. 500 millibars, again, fairly strong flow aloft for the most part. At least 50s overspread in the entire region, and 40s. This is winds at 925 millibars, so that's closer to the surface than 850 millibars, but they're almost just as strong, which led to a lot of low-level shear, meaning storms just kind of exploded and then were immediately tornadic as they formed. Finally, as we saw, low-level instability. This is 150 joules per kilogram shown here. This is the turning. This turning at the turning of the winds. This is SRH, so it's very similar to surface vorticity, but not as extreme. It's basically how much rotation a storm will have, and you can see that kind of that bullseye right there in the Chicago area. And STP, significant tornado parameter, with the website saying values over 1 to 2 are very high for our region. Now we're like the radar loop. There is a radar loop here, but I personally think it's a little bit less easy to understand. You can go through it. You can see storms fired right there around, pause it actually. You can see storms fired right there around 5 o'clock right down here, and then move on to the east. But they weren't very, very easy to look at. So we're going to look at the archive data from radar scope. First of all, this is basically as the storms are dying. This is right after they've died. You can see the cold front basically moving its way through. We go back to before. If I let this load real quick. Go back to before, and we'll look at all these storms forming. And I'm also going to be matching these up with our storm tracks a little bit. That's always something interesting, in my opinion. Load for me real quick. Yeah. Here's our radar loop. Go back. I'll click through it because it's much easier to do. You see our storm starting to fire here right out 448. That little showery activity, and then very quickly here, Sandwich, Illinois. Actually, that's somewhere I stopped too. Very quickly, you saw these ramp up. Now, I was right here in Yorkville, so I don't know if you saw that video. I was probably, I think the time of this video was right here. Might have been looking at this kind of forming, this little hook starting to form, but it wasn't very well defined yet until it would produce one of the first tornadoes of the day, which was out here near Oswego. So the hook is kind of weird to look at, but this is most likely the rotation in here. And it's not very well defined. You can see the inbounds here and kind of outbounds on the other side. Again, it doesn't help that we're so close to the radar, and it kind of damages look at it. Being close to the radar also is helpful at the same time because most of these storms are very surface based, and the rotations were very close to the surface as well. Don't forget these are EF0 and EF1 tornadoes. This is our first tornado. This is out here near Oswego. EF0, it lasted about 8 minutes, but you can see here the rotation ramps up a little bit for a few minutes, especially right here. This is when the website says that tornado genesis occurred. See pretty strong outbounds right here and pretty strong, outbounds not super strong, but much stronger inbounds right here. Some of these reaching almost 50 miles per hour as well. Yeah, almost 50 miles per hour inbounds, and then a little stronger outbounds as well. That was kind of our hook echo. Very strange shaped supercells this day, though. They weren't the typical looks, and then I believe very quickly after this would die out, but it did produce some damage. Up north here is also where a lot more of our tornadoes occurred. Right here in specific, or in particular, there was a little bit of rotation. This one is paired up with way up here near Timberlane, the 525 to 529. It's a very short-lived tornado according to this website. Tornado archive, by the way, it's very useful for the past events. Little bit of rotation in there. Again, that's also interesting to keep in mind because this is where our tornado would have been. But just looking at the data, yeah, right up here, probably somewhere in this area, but it's not very easy to see just because these things didn't have super strong mesocyclones. Might be able to get closer radar. Let's see if we get any other data from this. See if we can get a different frame right here. Might take a second as well. See a little more rotation here. If you look back into that last frame. This is after it's died out, but you can see the rotation a lot better from this more radar here in Wisconsin. I'm going to keep looking at the rest of the tornadoes now. The main tornado of the day, I believe, was this Elgin tornado. Also, there was one out here near the Midway Airport as well. So there's both airports of Chicago were nearly hit. Here's the O'Hare Airport. You can see two tornadoes. One lifts before it hits O'Hare. It also goes around it, and then the other one touches back down off the runways, barely missing this airport. We look down here to the Chicago Midway Airport as well. This one saw a very visible EF1 cone from the Midway Airport. It's very impressive pictures as well. Also, something I forgot to mention was how photogenic these tornadoes were. They were very easy to see. Here is, I believe, the Elgin. This is two tornadoes, right? This is the twin tornadoes, which were right here. These were twin tornadoes going on at the same time, but they were two separate rotations. It's not super strong. I don't very well defined here as well. You can see that funnel very well. Very wispy tornadoes. Damage tracks are also interesting. And you see the damage here. Nothing incredible, but some decent damage. Definitely not a good thing for obvious reasons. There's another picture of that Elgin tornado as well. Go back and find that Elgin tornado now. The radar loop probably. Ooh, this was a more cold front storm. So the cold front was our main forcing for a lot of the more stronger storm. There's another rotation embedded in here. I don't believe this one touched down, or unless this is the Algonquin tornado. Excuse me. So we're looking at that real quick by accident. The rotation pretty well in there. There's Algonquin. You can look at our map here. Let's see where it's Algonquin right here. This just went right to the east. The rotation from the cold front, just moving its way to the east. Strengthens here outside of Algonquin, weakens over Algonquin, and then it again strengthens after that. But these are a few EF0s. I believe the one before that was EF1 intensity. Which strange track, I will admit, though. Very interesting track to look at right there. And then we go south. We'll look at our Elgin storm. Again, these aren't very impressive storms. Structures are interesting. The only really impressive one was that EF1 near the Midway Airport. I'll look at that in a second as well. And there's Elgin. Yeah. So let's look at Elgin. You can see there's your much stronger uplite right there. Pretty well defined as well. Very strong tornado out of Elgin. And there were a few other. There's another tornado that went to the south of it. I can't see it very well on the radar. Also, it might have been it just didn't show up. It was at 618. So yeah, right in this radar frame, there should be two tornadoes on the ground. Looks like this actually might be the satellite. Let's check that. Actually, yeah, this looks like it's the EF0 right here. So that was their first tornado, their second tornado on the north. The north tornado was one that also strengthened and went south of Elgin, right? So there's other tornado. Then that would move to the east, and those would drop a few more later on into the night. The rotation just keeps continuing into the night there as well. But something important to note as well is that the lake also has quite an effect on tornadoes. So the lake is obviously stronger winds coming out of it. Means that you get a little bit of strengthening over in this area. But if you're closer to the lake, that means lower temperatures because of its lake effect. So if you're in the Chicago area, you know lake effect that often cools stuff, and that's part of the reason why in the summer Chicago is often being very cool. You don't really get many heat waves in Chicago. So in the part closer to the lake here, that often has cooler temperatures and that can dampen instability. So storms kind of die out right as they hit Lake Michigan. The storms off to the east, or sorry, the west here, I kind of circled everything, but you can see these storms were definitely strong, but once they hit the lake, they just kind of died out. You can see for the most part here, very strong updrafts here, and you'll check the Cicero storm in a second, but right as that reaches closer to the lake, these just start to kind of die out. You can see just immediately that red, the very strong red that was going out with that storm just gone immediately. So yeah, there's our looking at our Algonquin storm, looking at our Elgin storm, got this Yorkville storm or Oswego as well. Finally, we'll look at the Cicero storm. That one was interesting because that one was the very visible tornado there at Midway. Also had a very interesting hook echo when I looked at radar. This storm formed right around the tornado. Excuse me, the tornado formed right around 6:09. These are approximated, but for the most part, pretty accurate. These are 9 o'clock and 6:27. So look back at our radar. Actually see it very well here. So go back to before. Right here, this thing just kind of pops up. Actually, this is already ongoing. Excuse me. This is actually ongoing from I was looking at before. Yeah, there's your Oswego storm, and then kind of reproduces south from the ongoing convection. Kind of helps to reinitiate stuff later. This is about our time where it's forming. The issue here too is that the radar was so close to all these storms that it didn't give you good velocity data for close to it. That also kind of hurt for what you wanted to see. However, you can see the hook appendage right here. Kind of weird looking hook, but the next frame you can see it much better. The forward flank downdraft was not very well defined. We can see that hook kind of wrapping around right here. There's your hook, and then you're wrapping around. So imagine this as your supercell structure like that. Let me get a different picture, actually. Let's check out. Pink. There's your hook up, Hecko, and then kind of that forward flank downdraft ahead of it. Very strange looking supercells, but they were enough to create tornadoes. Move forward in this loop, you can definitely see the strong outbounds and inbounds. A little inbounds here, but stronger outbounds, indicative of that rotation. Here you can see a very well-defined hook, and then you really well-defined just where it's at. And for the most part, also the forward flank downdraft. Yeah, not very looking like supercells, but they were supercells. That would continue. There's your tornado. The rotation for it as well. Here's just an incredible look. I mean, you can see the hook, and then you can see the how disconnected from the precipitation the tornado was. Just how visible these were probably. Then after this would eventually dissipate right around here. About a 20-minute tornado, but after that they would dissipate, and also the Lake Michigan just kind of hurt this, I believe, too. That would dissipate and just kind of be showery activity. After that, I don't believe we saw too many other tornadoes. Again, we saw those rotations up here that might have produced one or two. Otherwise, that was about it for the day. So, always interesting to look at how these events happen. And one of the interesting things that came with this event was how sudden it was. Because in the morning of the day, if you lived up here and you looked at the SPC forecast, you lived in Schaumburg, for example, they were not in any tornado risk area. And then only about, I mean, what, 6 hours later, they were in a 10% hash rate for tornadoes. All of a sudden, this was a very sudden event. It also occurred right as everyone's trying to get home, too. So it's a very dangerous event. And luckily, we only saw EF1 intensity. Not that EF1 intensity is not strong, but we did not see any significant tornadoes. We didn't see what could have came out of this day. Something good that came out that really happened. I mean, again, they had this 10% hash region here. It could have been much worse, and we were lucky enough to not see that. So that was one of the things that happened too. The other interesting thing to me is just the fact that on the radar you can barely really see the supercellular structures. They're just kind of a mess. But the rotations were all over the place, and everything was so visible on this day. It was quite impressive. And otherwise, I mean, this event just holds a special place in my heart personally, so I want to cover it. Not much else to look at, though. Again, it is archive data. I couldn't find any radio sound soundings or SQTs or anything, but that's about what I could get. So, with that, thank you for watching. Hope you enjoyed, and I will see you next time.